Hey everyone, and welcome back to the Deep Dive. Today we are nestled in a cozy little coffee shop right here in Redmond, the heart of the tech world, right?
Yeah.
And I don't know about you, but I just love that aroma
Oh,
of
yeah.
fresh coffee and
Amazing.
C# code in the morning.
Yeah.
It's like the perfect blend, wouldn't you say?
Oh, it's invigorating.
It is. And today we're going to go on a deep dive into a method that's probably as familiar as your favorite latte order.
Okay. ToList. ToList.
ToList, of course.
It rolls right off the tongue, doesn't it?
Yeah.
But as with any tool, you really got to know how to use it to unlock its true potential.
Absolutely. And we've got some really fascinating articles and blog posts today that are going to help us explore those nuances. We've got some really great insights from Mike Treat, that's Trite, a 25-year Microsoft veteran. He's dedicated his career to really getting the most out of .NET and C# code when it comes to performance.
He's the kind of guy who can spot a performance bottleneck from a mile away. I mean, he's seen it all when it comes to ToList. The good, the bad, and the ugly.
Yeah, he's got some really strong opinions about ToList. But, I think starting off, why don't we just cover some of the basics? What is it about ToList that makes it so appealing to developers in the first place?
Well, I think it's the siren song of convenience.
Okay.
ToList can make your code look so much cleaner.
Yeah.
It reads more smoothly, and it just gives you this concrete list to work with, and you can, loop through it, manipulate it, and, just generally do all sorts of listy things with it.
It's like having all your ingredients prepped and ready to go
Exactly.
before you start cooking.
Right. Precisely. But just like how a well-stocked pantry can have a few expired jars hidden in the back, ToList, if you're not careful, can hide some performance costs.
Okay, so let's unpack those hidden costs a little.
Okay.
What is it about ToList that can really drag down performance?
Well, the biggest culprit is memory allocation. You see, ToList always creates a brand new list in memory.
Okay.
Even if the underlying data, it's already in a list. It's like making a photocopy of an already printed document.
Mm-hmm.
It's redundant. It's wasteful.
And I imagine all those copies start to pile up.
Exactly. And that's where the garbage collector comes in. Think of it as the cleanup crew for your computer's memory.
Okay.
It's constantly working behind the scenes to reclaim memory that's no longer being used. So, the more unnecessary objects we create, the harder the garbage collector has to work.
Gotcha.
And this can lead to those performance hiccups and slowdowns.
So it's like having your cleanup crew constantly chasing after you while you're making a mess.
Precisely. And one of the worst offenders, in my opinion, is when you combine ToList with the for each method.
Yeah, we've got this one blog post that really gets fired up.
Oh, yeah, I saw that one.
About this. The author, they call for each on a list a tragic pit of failure and a betrayal of LionQ's elegance. Strong words.
Yeah, very strong.
Yeah, they're not holding back. But I think they have a point. They argue that for each, it doesn't really belong in the world of LionQ, because LionQ is all about functional programming, elegant transformations.
Yes.
And for each really kind of goes against that.
It encourages this clunky pattern where you're creating an unnecessary list just to iterate over it.
Yeah, and they give a really clear example to kind of drive this point home. They have this little snippet of code where someone is sorting a list, then they call ToList, and then they use for each to perform some action on each item in the list, kind of a common pattern.
Yeah, I've seen that before.
And the author's basically saying, hey, you can do the same thing with a simple for each loop.
Much more efficient.
Yeah, totally avoid the overhead of creating that new list.
Yeah.
It's like taking a scenic detour when you could have taken the highway straight to your destination.
I love that analogy.
Right. And they even go so far as to provide their own custom for each extension method that operates directly on IEnumerable.
Oh, wow.
So they're totally bypassing ToList altogether. It's like they're saying, here's a better way, folks. Stop making this common mistake.
I admire their passion. It really shows they care about writing clean, efficient, and elegant code.
For sure. Okay, so we've established that ToList always allocates memory for this new list, but what about those cases where the underlying data is already a list?
Okay.
Is ToList smart enough to just return the original list?
That's a great question.
And avoid that unnecessary copying?
You would think so, right? Unfortunately, no. This is actually a really common misconception among developers.
Really?
Yeah. A lot of people think that ToList can be clever enough to detect those situations and optimize accordingly.
Interesting.
But the truth is, ToList always creates a new list, no matter what.
But why is that? I mean, it just seems so wasteful.
Well, it comes down to consistency and thread safety. ToList always produces a brand new list to ensure predictable behavior, especially in multi-threaded scenarios where you might have multiple threads trying to access
Yeah.
and modify the same list. You don't want them all fighting over the same resource, right?
Right.
So it's better to be a little redundant
Okay.
than to risk data corruption or unpredictable behavior.
So it's kind of like taking the safe route,
Exactly.
even if it means, a little bit of extra work.
You got it. It's better to be safe than sorry.
This reminds me of something that Casey Murator, the game developer, talks about. He calls it non-pessimization. Have you heard of
I
that?
have. It's a fascinating concept.
Yeah, he's basically saying that we often write code that's pessimized without even realizing it.
Right. Yeah.
We make the computer do way more work than it needs to because we're not really thinking about the implications of our choices. Like all those little inefficiencies.
It's death by 1,000 cuts for your code's performance.
And I think ToList, especially when you pair it with for each, that's like the prime example of this, of non-pessimization in action.
Oh, absolutely. We're basically setting up all these roadblocks for our code to stumble over, and it just slows everything down.
Yeah, it's the opposite of what we should be striving
But
for.
we should be aiming for optimization, streamlining.
Exactly. Speaking of which, I think it's time we talk about Mike Treat's bad code radar.
Oh, yeah, this is a good one.
He's got this PowerShell function,
Yeah.
and it uses regular expressions to basically sniff out potential ToList misuses.
It's like he's built a code linter that's specifically designed to catch these performance gremlins.
Yeah, it's pretty impressive. His regex looks for those classic red flags, like calls to ToList or array in the middle of a LINQ chain, or unnecessary checks for list lengths and all those other telltale signs that we might be creating unnecessary lists.
It's like having a seasoned detective looking over your shoulder, pointing out all the clues that might lead to a performance crime.
Yeah, and the cool thing is it's customizable, right?
Yeah.
You can take his regex and adapt it to your own coding style and the specific anti-patterns that you're trying to avoid.
It's like having a personalized performance coach right there in your IDE.
I love that.
Yeah.
Now, to really see these principles in action, let's look at one of Mike's case studies.
Okay.
This is where he analyzes different approaches to extracting keys from a list of key value pairs. So there are 5 different ways to do this,
Yeah.
and the performance differences are pretty shocking.
Yeah, this is where the rubber meets the road.
Exactly. It's not just about the theory. It's about seeing how these decisions can lead to real-world performance gains. So in the original code, which was flagged by Mike's bad code regex, ToList is used multiple times, and it ends up being significantly slower
Right.
and uses way more memory
Of course.
than the other approaches. It just goes to show that even small choices, they can have a huge impact on
So
performance.
every little bit counts.
Exactly. But here's where things take a bit of an unexpected turn. Mike then shows us this really weird-looking piece of code from the Newtonsoft.json codebase. You familiar with that?
Yeah, I've used that library. It's pretty popular.
Yeah, it's used by millions of developers. And guess what? They use ToList followed by ToArray.
ToList and then ToArray.
Oh, no.
That seems redundant. It's like converting a physical book to a digital format and then printing it out again.
Right. It's like, what's the point? But there's actually a method to the madness here. It turns out that this code was written back in the days of .NET Framework 2.0.
Oh, wow. So this is legacy code.
Legacy code. And there were some limitations back then that made this approach necessary to avoid Stack Overflow errors.
Ah, the quirks of legacy code. Sometimes you got to make these seemingly illogical choices just to work around constraints.
Exactly. And this is why comments are so important.
Couldn't agree more.
Because in this case, the developers left a comment explaining why they were doing this ToList ToArray dance. It's like leaving a note for your future self, saying, hey, I know this looks weird, but here's why I did it.
Comments are lifesavers when you're trying to understand the reasoning behind unconventional code.
Right. And so the lesson here is that even when code seems blatantly wrong, there might be a deeper context that we need to understand before we start judging.
Always be curious.
Be curious.
There's often more to the story than meets the eye.
Absolutely. It's like being a code archaeologist,
Yeah.
unearthing these layers of history and rationale behind just this one line of code.
I love that analogy. And those layers often reveal a lot about the evolution of technology and just the ingenuity of the developers who came before us,
Yeah.
solving problems with the tools that they had at the time.
Speaking of ingenuity, I think this whole ToList conversation really highlights how important it is for us as developers to really understand how things work under the hood.
Oh, absolutely.
We have all these amazing tools, these libraries at our fingertips.
Powerful tools.
But we got to use them with intentionality.
You got to be mindful.
Mindful.
It's like, driving a car.
Okay.
You don't need to be a mechanic to get from point A to point B, but understanding, just the basics of how the engine works can really help you avoid breakdowns and, drive more efficiently, maybe even enjoy the ride a little bit more.
And in the world of software development, that engine is often the .NET runtime and the C# language itself.
Exactly.
And knowing how those systems work,
Mm-hmm.
How they manage memory, how they handle collections, how they execute code, that can make all the difference in the world when it comes to writing performant and reliable software.
It's about respecting the power of these tools and using them responsibly.
Yeah. And that brings us back to that blog post that we were talking about before. The author, they argue that the real tragedy of ToList isn't just the performance hit, but this loss of awareness.
Right. It's a great point.
This loss of awareness about those performance considerations. And, they trace this back to the early days of computing when memory was super precious, right?
Oh, yeah. Every byte mattered back then.
Every byte mattered. Developers had to be so frugal, so efficient to make the most of what little they had. And then hardware's gotten more powerful, memory's more abundant, and maybe we've gotten a little, complacent.
A little bit. It's like we've inherited this spacious mansion and we're just leaving the lights on in every room because we can afford the electricity bill.
But even though we might not see those immediate consequences, I imagine, those inefficiencies, they start to add up.
They do. They lead to slower applications, increased resource consumption, and ultimately it's just a less satisfying user experience.
And the author really nails it when they say it's not just about performance, it's about craftsmanship.
Right.
Taking the time to understand these nuances and write efficient code, it's a mark of a skilled developer.
It's like the difference between a carpenter who just throws together a table with nails and glue and one who, meticulously crafts these beautiful dovetail joints.
Yeah. Both tables might hold your dinner.
Right.
But one of them just shows that extra level of care and attention to detail that's really admirable.
It's beautiful to see.
So what can we as developers do to avoid falling into that ToList trap or really any performance pitfalls? What advice would you give to those striving to write more efficient and elegant code?
Well, first and foremost, I would say be mindful. Think critically about each ToList that you encounter in your code.
Okay.
Ask yourself, is this truly necessary? Is there a more efficient way to achieve the same outcome without creating this unnecessary copy?
It's about being intentional with our code, not just blindly following patterns or reaching for the first solution that pops into our head.
Exactly. And don't be afraid to experiment. Try different approaches, measure the performance, see what works best for your particular use case, because there's often multiple ways to solve a problem, and some solutions are just inherently more efficient than others.
I love how in that blog post, the author really demonstrates this with those code examples, right?
Yes.
It's those subtle little changes in the order of operations that can have a big impact on performance.
It can be eye-opening, for sure. It shows that you need to understand not only what each method does, but how it interacts with the other methods in the chain.
And speaking of chains, I think Mike Treat's bad code rejects is just a brilliant example of how we can use tools to augment our intuition and help us spot those potential issues.
Oh, it's fantastic. It's like having a second pair of eyes that are specifically trained to look for those signs of inefficiency.
Yeah. It's like a code linter that's laser focused on performance, gently nudging us towards better practices.
I love it.
And the best part is that it's customizable. You can adapt it to your own style, the anti-patterns you want to avoid, the challenges of your projects.
It's a great starting point. And you can even create your own set of, bad code rules or heuristics based on your experience and what your team needs.
It's like, building a performance playbook that evolves over time.
Exactly.
Yeah.
It's a living document.
There's also this interesting point that the author makes about the use of the discard character, the underscore as a variable name. They argue that while it can be concise, it can also obscure intent.
It's a stylistic choice that can be a double-edged sword.
Yeah.
On one hand, it can streamline your code and make it more readable. But if you overuse it, It can lead to ambiguity, making it harder for others, or even your future self, to understand what's going on.
It's all about that balance between conciseness and clarity.
Absolutely. Code is not just instructions for the computer, it's communication between developers.
Exactly.
And good communication is about conveying meaning clearly and effectively.
And this brings us back to the importance of comments, especially when you're dealing with unconventional code,
Oh, absolutely.
like that two-array example.
Oh, right.
The comment really provided that context,
It explained why they were doing something that seemed so counterintuitive.
It's like leaving a note for your future self, explaining why you put that random object in the back of the fridge.
Exactly. You might not remember the reason now, but you'll be thankful for that reminder later. And it's not just for your future self, it's for your colleagues who might have to work with your code later.
For sure. Clear comments can make such a big difference in helping others understand your intentions, avoid bugs, and just maintain that code base effectively.
They're essential for collaboration.
So, just to come full circle here, one of the big takeaways from that blog post is this idea that the real tragedy of ToList is this loss of awareness about performance.
It is a sobering thought. We've become so accustomed to the convenience of modern programming languages and the power of modern hardware that we've, kind of lost some of that low-level awareness that was crucial in the early days.
It's like we've traded in our manual transmission for an automatic and we've forgotten how to shift gears.
Exactly. But it's not too late to relearn those skills. And it's not about going back to the dark ages of assembly language, but it's about appreciating the power of abstraction while still understanding the underlying mechanisms.
Being informed drivers, not just passengers.
Precisely. And that's what makes discussions like this so valuable.
Yeah.
It's not just about learning how to use a specific method, but cultivating this mindset of continuous learning and performance awareness.
So as we savor those last sips of our Redmond coffee here, what's the one thing you want our listeners to take away from today's conversation? What's that nugget of wisdom that they can carry with them on their coding journey?
I would say be curious. Don't just accept things at face value. Dig deeper. Ask questions. Challenge assumptions. The more you understand about how things work under the hood, the better equipped you'll be to write efficient, maintainable, and elegant code.
Yeah, and it's like a muscle, that curiosity. The more you exercise it, the stronger it gets.
Absolutely. It's all about cultivating that growth mindset, always trying to learn more and improve our skills.
Speaking of improvement, at the end of that blog post, the author gives this really great call to action. And it's actually inspired by Mike Treat and his approach. They challenge us to come up with our own bad code rejects or even just a set of rules to help us spot those potential performance problems in our own code.
I love that. It's like a personalized performance checklist for our code.
Right. It's brilliant. It encourages us to be proactive about efficiency, and it really reminds us that we can all play a part in building a better code base, making it more robust, more performant, more elegant.
And it can be fun too, right?
Yeah. It's like a game. Who can come up with the cleverest rejects or the most insightful set of rules?
Exactly. And it's a game with real rewards. The more efficient our code is, the better our applications will perform, the happier our users will be, and our software will just be more sustainable in the long run.
Absolutely. Well, as we wrap up our deep dive here in Redmond, the birthplace of so much innovation, let's raise a virtual toast to curiosity, to continuous learning, and to the pursuit of efficient and elegant code.
Cheers to that. May your code be clean, your performance be stellar, and your coffee be strong.
And on that note, thanks everyone for joining us on this exploration of ToList and all the nuances of performance optimization. It's been a real pleasure.
The pleasure was all mine. Until next time, keep coding smart.